Students, in the previous class, what I discussed, it is about the crystal frequency and how do this crystal, it is connected, and this crystal, how it is in turn running the entire microcontroller I was discussing. But when you go for this crystal, as I told you, it is able to generate 1 megahertz to 16 megahertz different clock frequencies, variable clock frequencies. And these frequencies, when you are considering any one frequency, your 8051 will be using out of 1 to 12 megahertz. But when you look at this 8051 C82D, this is a latest version of 8051. So the clock frequency that is going to be used is of how much? How much is the clock frequency? Please let me know the answer from you. How much is the clock frequency? That is the last topic that I discussed in the previous class. Students, answer to the question.
11.05 megahertz.
Yeah, 11.0592 megahertz. So this 0.0592 megahertz, I've told you it is a decimal part of the frequency. Why they have kept means, because when you use and make use on computer or on microcontroller, it supports for various baud rates. Baud rate is nothing but the number of bits per second the microcontroller or the microprocessor based computers can transmit and receive. If you look at the serial communication, there are different baud rates. Which are the baud rates? You can see 1000. The standard baud rate which you will fix for the serial communication is 9600 bits per second. So what is this 9000? Otherwise you can go for 4800 bits per second. So when you compare this 4800 bits per second with 9600 bits per second, the computer, it is transmitting the data or receiving the data with much faster rate compared to the 4800 bits per second. So now when you go for this microcontroller, you can see various baud rates: 1800, 18200, sorry, 19200 bits per second, all these things. But for the serial communication, in 8051, the standard baud rate which we'll be using for any of the communications is 9600 bits per second. It is termed to be the baud rate. So to support various baud rates is nothing but the transmission and or the reception capacity of any microcontroller or microprocessor during serial communication. In order to support for the varied baud rates, the clock frequency of 8051, it is fixed to 11.0592 megahertz. How do we derive this? Because your frequency of the crystal is ranging from which frequency to which frequency? It is ranging from 1 megahertz to 12 megahertz. But how do this type of the decimal frequency we are going to derive means, it is through the divide by counters. Internally there will be counters. These counters function is to divide this 12 megahertz clock frequency to get this baud rate. So this is about the previous class, crystal oscillator and clock frequency of 8051. In continuation to this, the problems, let us solve one or two. What are these problems? Why we are taking the problems at this point itself means because one question we have to answer from this topic. It is to find the instruction time period. Instruction time period. How do we calculate this instruction time period? Any one instruction time period. How do you calculate? One formula we have used, that is C into
quality by frequency.
by
Crystal,
frequency of the
crystal.
crystal. Okay. So now, since the timing of every instruction, the time by the controller which is going to utilize for any instruction execution, since we'll be calculating based on this formula, in this formula, C is one machine cycle. C represents the, in general, how do you uh, tell this C or define this C? C is nothing but the number of machine cycles. Number of machine cycles. So this machine cycle, you know, one machine cycle is equal to what? One machine cycle is equal to
6 states.
6 states. Very good. One state is equal to
2 periods.
2 clock periods. One state is nothing but 2 clock periods. Clock periods, how do we represent? These periods we will be representing as T. So first we need to find out the how do we solve any given question means first the clock frequency they will be defining in the question. From there you have to define the clock period, and from that frequency once you derive the clock period, that is T, then you can go for machine cycles, and from the machine cycle time you can find out each instruction how many machine cycles it is utilizing. Based on that you can calculate the instruction period. So now one problem let me solve now in this class. So the problem one, it is calculate the period of or period of one machine cycle m slash c, that is in shortcut I am using for machine cycle of crystal of machine cycle of 8051 if crystal frequency is first case 16 megahertz. The second case you need to find out for 12 megahertz. Is it clear the question?
Ma'am, PDF is not seen, ma'am.
Yes?
We cannot see anything, ma'am.
Oh, I am not. Sorry. You didn't screen when you are not able to see first itself. You have to tell me. Huh? 1 minute. Okay. Now we are able to see, right?
Yes, ma'am.
Yeah. You please first itself you let me know that from your side there is a screen not visible. Can I show you those whatever I have written? Yeah, this is what today's write up I have written. Anyhow, I'll be sharing. Most of you might have written while explaining. different baud rates. What are the baud rates? If you go for higher baud rates, the faster will be the system, and if it is lower the baud rate, the system will be the slower. In any of the baud rates, the number of bits per second, since it is going to be transmitted, time per second, how many bits to compute frequency we will be using, that is generated by crystal, and inside there will be divided by n counters. Based using those counters, will derive one fractional part of this clock frequency 11.0592. So any question or any instructions execution time, if you want to compute, you have to make use one formula that is already defined or discussed. C into 12D divided by F of crystal. In this, the C represents the number of machine cycles, and one machine cycle, since it forms, it uses 6 states, and each state, when it is considered, it uses 2 clock pulses. Since in the 2 clock pulses, the minimum time period is T, that T we have to derive. How do you derive this T? How do you derive this T? Yeah. Okay, reciprocal of frequency. That is what we have discussed. And now, with respect to the next problem, two problems I'll be solving. One is calculate the period of one machine cycle of 8051 if the crystal frequency that is used by 8051 is in the first case 16 megahertz and in the second case 12 megahertz. So how do you solve this problem? Can anyone start guiding me to derive the solution? First step is what we have to find out, because whenever we are solving the problems, we have to go in an reverse way. First step is to find clock period. How do you calculate the clock period in the case 1? Students, be interactive.
1 by 16 into 10 power
6,
6.
1 by 16 megahertz is your T, right? So this you can write it as 1 by 16 into 10 to the power of 6. That is time seconds. So how much ever seconds you will get? Okay. Now you have to calculate the one machine cycle period or time. How do you calculate this one machine cycle period? One machine cycle is nothing but 6 states,
2 into
and
6.
yeah, this 6 into one state represents what? 2 clock periods, right? 6 into 2 into what is time period? T. 1 by 16 into 10 to the power of 6. Is it correct?
Yes, ma'am.
Yeah. So now, if 12 by 16, how much approximately you will get? 12 by 16 into 10 to the power of plus 6. So it is 12 by 16.75 into 10 to the power of minus 6. So this is equal to what? In terms of
Microhertz, ma'am.
no, time, reciprocal, what is the unit of time?
Seconds.
1 T for one machine cycle, right? It is equal to 0.75 microseconds. Is it clear for everyone?
Yes, ma'am.
Because in the rest of the modules, when we go for writing the programs between one task to another task, we need to provide delays. Those delays, how we will be providing in 8051? That is through the instructions. Whenever delay you are calculating, these are the various procedures you will be following. What is the next clock frequency? What is the next clock frequency? In the second case, 12 megahertz. Yeah. A T time period of one machine cycle, how do you calculate? It is equal to 6 into, correct? 6 states into 2 into, each state represents 2 clock cycles. So what is the time? That is 1 by 12 into 10 to the power of 6. Directly I am writing, substituting. Are you able to understand?
Yes, ma'am.
Yeah, 1 into 10 to the power of minus 6. How much is this? It is equal to 1 microsecond. Is it clear?
Yes, ma'am.
Yeah. In this, let me ask you one question. Suppose one instruction I am taking. One instruction, say for example, it is mul AB. It is an instruction which is multiplying two operand values A and B. And this particular instruction, it is going to make use 4 machine cycles. Can you tell me what is the total time that is required for this mul AB to execute by the 8051? It requires time for the instruction mul AB. How much it will be? In this case only, for the second case only, one instruction I am taking, that is mul AB. It is an example I am taking. This particular instruction, how many machine cycles it is using? It is using 4 machine cycles. Then I wanted to find out the total time that is required for this multiplication instruction to execute by 8051. How do you calculate? C into
2D by
12D divided by T. Yes or no?
F, ma'am.
Sorry, 1F. Okay. C is how much now? C represents the number of machine cycles. 4 machine cycles into 12D into 1 by F is T. T is how much? 1 microsecond. How much is this equivalent? Oh, sorry. Yeah, what is this is 1 machine cycles, right? 12D won't come. How much is the total period of this instruction? This is the general formula you are using for an instruction. But now I have the 4 machine cycles. 4 into 4 into this 12D by F is nothing but what? 1 time period of 1 machine cycle. Right? So now 4 into 1 microsecond is the total time period. So total time of this instruction is how much? How much?
4 microseconds.
4 microsecond. Is it clear or any doubt? See, this is a general formula we are using. This particular thing is a general formula we are using. Already one machines, this particular 12D by F gives what? 1 machine cycle period. So that 12D by F already we have calculated. It is computed around, in the second case, 1 microsecond. So therefore, the total time required for one instruction to calculate is 1 microsecond. So let us move on to next problem. That is the problem number 2. In this problem, In 8051, in 8051 system, clock is 11.0592 megahertz. Find the time taken for an instruction which takes 4 machine cycles. Yeah, please let me get the solution from your side. What is the solution? Now directly you can make use the instruction. Sorry, the formula. T instruction, it is equal to C into 12D divided by F. How many machine cycles? C represents machine cycles. How many machine cycles?
4.
4 machine cycles. Multiply this with 12D divided by, what is the frequency?
11.059 megahertz.
592 megahertz. Okay. If you are calculating the total time period required for this instruction to execute, if you calculate, you will be getting this as 4.34 microseconds. Is it clear? Students, if you have any doubt, you can ask me. Otherwise, I'll go for next to switch over to next topic. Any doubt?
No, ma'am.
Shall I proceed? Okay. Next topic in this module, whatever module 1, the topic number 4. Topic number 5. It is the pin diagram of of 8051. What is this pin diagram of 8051 means? Whenever you go for this microcontroller 8051, because this is a chip on, it is a chip, that is here, it is an IC. It will be available for you in the since it is available in the form of an IC, you have to know what are the various external pins for this 8051 which are available. So for that, you have 8051 pin diagram. So now let us take this pin diagram. Afterwards, I'll explain the each pin detail. So this pin detail of 8051, if you are taking, so it is an 40 pin IC. So 40 pin dual in package. What do you mean by dual in package? Which will be available in the form of NMOS technology or in the form of CMOS technology. So this is an 8051 IC structure. Dual in package means all the pins, 40 pins, will be arranged on left side and right side only. And there are IC squad pin. You can see in your personal computer's motherboard. Some ICs, they will be having the pins on all the four sides. When you look at this pin detail of 8051, left side, since it is a 40 pin IC, left side 20 pins and right side 20 pins, as you have seen, like same in your DSD lab. The left topmost corner pin will be 1, 2, 3. It will increase like this: 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I'll first write the pin details and then later I'll explain the pin pin diagram. I'll explain. First write the pin diagram and then I'll explain pin details. 16, 17, 18, 19, 20. So left side 20 and right side also you can see 20. So here 20 opposite. I'll write 20 inside because I have to write the pin details the other side. 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. The rest of the pins are how many? Another 10 pins. Here you can see 31, 32, 33, 34, 35, 36, 37, 38, 39, and 40. Okay, this is how the pins, it is pin diagram of your 8051. Then what each pin represents. Any IC you take, the left top corner down, it is ground, and rightmost top corner, it is VCC pin, VCC and ground. What are the rest of the pins? The rest of the pins are represented as P1.0, P1.1, P1.2, P1.3, P1.4, P1.5, P1.6, P1.7. Totally how many pins I have written?
8 pins.
8.
8 pins. These pins are represented as P1. Capital P1 means port 1 pins. The 9th pin is an RST pin, that is reset pin. The 10th pin, it is P3.0, P3.1, P3.2, P3.4, sorry, 3, P3.4, P3.5. I've shared any of the notes, you can refer, but you can listen. P3.7. Yeah, here again, how many pins you can see? How many pins?
8, ma'am.
8 pins. These pins are represented as capital P3 pins or port 3 pins. So if you look at this port 3 pins, there is another function which is embedded with this, that is RxD. RxD slash P3.1. Sorry, this is RxD. 1 minute. This up to this is here P3. This first pin P3.0, it does other function also as RxD. So P3.1, it does another function as TXD. That is, and P3.2, it is INT0. INT0. And this pin's other function is INT1. And this pin P3.4, it is timer 0. This P3.5, timer 1. In detail, I will be explaining. And P3.6, it is used for write bar. So another pin P3. It is used for read bar. Okay. These are the pins. So you have the rest 18 and 19th pin. This 18th pin is Xtal2. If you remember when I was explaining the crystal oscillator, I have taken 2 pins of 8051, that is 18 and 19. So between these 2 pins, the crystal oscillator will be connected to generate the crystal frequency for 8051. Now, moving on to the right side pins, how many ports still we have to take? Port 2 and port 1, port 0. Port 2.0, port 2.1, port 2.2, port 2.3, port 2.4, P2.5, P2.6, P2.6, P2.7. Totally how many pins? 28th pin up to here. You can see it is port 2. This port 2 pins, again they have connected to another functionality pin, that is A15 slash A14 slash A13. I'll be explaining each one. What is this? A12, A11, A10, A9, A8. Okay, these are the pins which are connected to port 2, which are multiplexed. If you look at this pin number 29, it is program strobe enable, that is PSEN bar. And then 30th pin is ALE or PROG program. Whether a prom is to be written or it has to be multiplexed, that will be decided by ALE. And 31st pin is VPP or EA bar. Okay. How many pins left out now? 32 to 40. 39. How many pins? 32 to 39. 8 pins. All these 8 pins, let me represent here as port 0.0, port 0.1, port 0.2, port 0.3, port 0.4, port 0.5, port 0.6, port 0.7. And these pins have been multiplexed with address and data. AD0, this is with AD1, this is with AD2, This is with AD3. This is with AD4. This is with AD5. This is with AD6. And this is with AD7. So all these P0.0 to P0.7, totally 8 pins, they are represented as port 0 pins. Is it clear? Students, can you see the pins how they have organized with this 8051?
Yes, ma'am.
Yes, ma'am. Now, because we have to know that what are this P0.1 or P1.0, all these things, what is this ground, how much is the voltage for VCC. To know more about these pin details, so let us consider the pin details explanation. Coming to the explanation of this pin diagram, if you look at the 8051 pins, totally how many pins you can see? You are able to observe 40 pins, which are arranged in the form of dual-in package form. And in this, another observation you might have done it. Most of the pins are multiplexed, means they have connected with multiple functions. Many pins of 8051 are used for multiple purpose, multi-function. More than one function, it is termed to be a multi-function. Okay, now these pins, whatever we have seen in the 8051, we will categorize into various categories. So 32 pins of 8051 out of 40 pins are grouped for our IO pins, input, output pins. So input output pins, it is also in short we'll be representing as IO pins, and can be configured, and these can be configured. You can see they can be configured as IO pins. How we have configured? 4 ports, 4 parallel ports. For 32 pins, when they are configured into 4 parallel ports, how will you represent the as port 0, port 1, port 2, port 3? This is how we'll be representing port 0. It is of 8 pins. Port 1, 8 pins. Port 2, 8 pins. Port 3, 8 pins. Students, are you able
Ma'am, you're on mute.
Ma'am, you're in mute.
Yeah. Now we can see 32 pins which are used for input output operations. Now, how, and also we have seen that they have configured for input output. Apart from that, most of the pins, if you are taking port 0, how are you representing port 0 8 pins? We are representing as port 0 dot 0, port 0 dot 1, port 0 dot 2, and so on up to port 0 dot 7. So similarly, your port 1 and this port 0, whenever we are using capital P0, we'll be using. When we have to use capital P1, P2, capital P3. I'll tell you there is a lot of difference between this small p and this capital P. What is that? I'll explain when I take up the, what is that, programming model of 8051. So now the port 1 also, if you take this port 1 P1 dot 0 to P1 dot 7, and similarly your port 2, port 2, if you are looking, you can represent this as port 2 dot 0 to port 2 dot 7, and similarly port 3, port 3, it is P3 dot 0 to P3 dot 7. Clear? 8 plus 8 plus 8 plus 8. So 32 pins. Now, these port pins, since they does not do a single function, they are able to perform many functions. They are all multiplexed. So hence, all port pins except your port 0, port 2, and port 3, all are multiplexed. Multiplexed. This is the one property you should know when you go for this pin diagram. Another property is that any pin of 8051, any pin that is IO pin of 8051, all the 3 or 4 ports pins, if you are considering, is bidirectional. Okay, what do you mean by bidirectional? Means it is whenever you take any pin, suppose P0 dot 0, this pin is able to send data and able to from external world. This is to send data to the external world, and from the external world it is able to receive, from the external able world to receive into the microcontroller. This P0 dot 0 where it is connected to the 8051. So through any of these pins, the 8051 is able to take the data as well as send the data. Hence, they are termed to be the bidirectional pins. Okay, now how these different functionalities of all the ports are connected to 8051. If you take the internal architecture, just I've showed you the port 0, port 1, port 2. But when you internally, the complete circuitry, when it is considered, your port, any port, it is connected to external world through the latch, buffer, and driver. So now there is an buffer, the port 0, port 0 output driver. Okay, now if you look at this port 0 output driver, what is the output of each port means? the pins only we'll be seeing like this. So 8 pins, you can see all the 8 pins, how they are, for what functions they have configured means each pin, port 0 pin, it can act as a input port or output port. Okay, or it can take the least significant address data. It can take least significant bit data also. So like this, you can see the different functionalities. So in general, if I'm writing all the pins of port 0, so what I'll be writing, so let me tell you, because that is what I've written, it is for your explanation purpose. Now, if you take up this, what are the 0, 1, etc. up to 7, 8 pins are there. It can be used for input output operations. It can be used to hold the address ranging from A0 to A7. It can also be used to hold the data D0 to D7. Hence, any port 3, port 0 dot X, this X represents 0, 1, 2, 3. It is nothing but IO operation it may be able to do. It is able to take any data bit, or it is able to carry any address bit. So that is what the simplest way to represent port 0. Similarly, one more port which is connected to external directly, it is not connected because CMOS based you cannot connect externally to the real world. So it requires the latch driver. So another latch one with buffer and driver, they have connected to the port 1. If you look at this port 1, output driver, through the port 1 output driver, the driver is able to give an output of only port 1.0, etc. Next pin will be, so why I am writing bidirectional, you might have understood, port 1.1, etc. port 1.7. Any other functionalities have been multiplexed here? No. Hence, it is used only for IO systems to operate, input output systems to operate. If you go for the next port, which is the next port? Students, please talk. Which is the next port? Yes?
Port 2, ma'am.
Port 2. So you have here port 2. It should also have the output driver. And here it is able to, since it is multiplexed, each pin represented as P2.0, etc. It is multiplexed with a 8, etc. The last pin, 0th to 7th pin of port 2, it is multiplexed with address. So therefore, the last pin of port 2, P2.7 with A15. So if you are observing, what are the two functions this port is able to do? Port 2, it is able to transfer the data for input output operations. Also, it is able to hold the higher order address, that is A8 to A15. The last pin, which is the last port pins, port 3. Port 3 also, it will have one latch that we are representing as latch 3, buffer, there. You can look at here, port 3, driver, TTL. In order to make TTL compatibility, are to sync the driving current, syncing sourcing currents. We will be going for drivers. If you are thoroughly, you have studied the ED, you might have known by this time what is a driver circuit is. P3 dot 0, it is ranging from P3 dot sorry, here I'll write P3 dot 0, and it goes up to P3 dot 7. So what are the functions it is able to do? IO, then serial transfers, see interrupts. It is able to interrupt the control. It controls the interrupts. It is able to control the timers. It is able to
Read.
control the memory read as well as write operations. Is it clear, students? The port pins, how are they are organized?
Yes, ma'am.
Yeah. I think at this point I'll stop today's class. In the next class, I'll continue with the port each pin's explanation. Okay. Please, relevant to this, whatever the today's explanation which I have done, notes I have shared already in your group, and this write up notes, class write up notes also I'll share it to you. Please go through. If you have any doubts at the end of or in the beginning of next class, you can ask or you can post me the questions or doubts in your class group only so that I can answer. Fine. Up to 10:50, right? The class.
Yes, ma'am.
See, initially I may go a bit slow, but afterwards you can